There's a few terms that I want to go over because we're going to use pieces of these. We're going to use these terms as we move forward and get into some of the detail of sampling. The first term is an element. An element is a single unit that I'm going to pull out in order to sample. So if I'm interested in people, the element would be a person. The population is the group that I'm interested in talking about. So that's the large group, all people that are depressed, or people that show up at my clinic, or all homeless youth, or kids in the foster care system, or kids that have been reunified with their families from the foster care system. So whatever that large group of people is, that's the population. Now, in order to move from that population to my sample, I develop a sampling frame. So I might say, I want to sample only within X number of clinics. So if I'm interested in sampling from community mental health clinics in Maryland, and I want to make a statement about clients associated with community health clinics in Maryland, I might say, I'm going to take the list of folks, of clinics from the Maryland Clinic Association. I don't know what the organization's called, but there's some organization that represents all of the mental health clinics. And I can get a list from them, and then I can randomly select from that population. But that list would then become my sampling frame, the thing that I use to draw my sample from. The study sample would be the group of elements that I pull out of that sampling frame from the population and put into a collection and then measure. To put that in context, I have a population of people that I'm interested in. I have some way of organizing that and putting it into a frame, so a list of all clinics in Maryland, for example. And then I randomly, or by some mechanism, draw out elements, pieces, clinics in this case, from that sampling frame, and then those become my study sample. So there might be 100 clinics in Maryland. I choose 10 of those clinics. And those 10 clinics I'm using to represent all 1,000 clinics in Maryland. So I take a large population, I define it in some way, I pull from among those, and then that group of elements that I have pulled out of the population through my sampling frame is my study sample. When thinking about sampling, and the appropriateness of sampling, you want to ask a few basic questions of the sample. One is, who do you want to know about? Have you used a good inclusion criterion? We'll define that term in a second. Have you made a good decision about who gets into the study and who is kept out of the study? And that's crucial to having an unbiased sample. How many people do you need to sample in order to answer your question? And there's a whole host of things we'll talk about when we get to quantitative and qualitative analysis about how to answer that question specifically. As a rule of thumb, you want at least 20 units of whatever the elements are in order to make any inferences about it. So anytime I calculate a mean or an average or any other statistic, I want at least 20 of those things that I'm counting in order to get a good number. Now, it can vary a lot, but as a good rule of thumb, 20 is a good number to start with. I want thousands or millions, but often I have to settle for a few. And these questions of sample size are often the most difficult thing for investigators to do, because each interview, each process that I go through to get data about somebody consumes a lot of resources, so it's expensive. So the more I sample, the more cost I have. So sample size is often something we're bumping up against as investigators or people conducting a study. So you, as an evaluator and appraiser of evidence, want to think hard and think long and hard about sample size, and do they have enough people in their sample in order to make good inferences about the population that they're talking about. And finally, we have to be realistic. Just as with control groups, sometimes it's not possible to do random samples. Sometimes convenience sampling is necessary. I think I've mentioned before, I do some work in investigating heroin use. And we have in part of this research collaborative that I'm part of, we have some qualitative researchers that go out and do interviews with people. Well, we can't do random digit dialing to sample from among heroin users. There's just not enough heroin users in the population to realistically find people, and people are hesitant for obvious reasons to tell you over the phone that they inject heroin. So what we do is we use something called snowball sampling. We'll talk about that a little bit more later. But the idea is that we use people that we know, that we've already interviewed, to find out who they know that also uses heroin, and then we interview those people. So sometimes it's just not feasible or practical to use randomness or random digit dialing or these other techniques to get a sample. Sometimes we have to use what's feasible for us. So feasibility always enters into the question. Inclusion and exclusion criteria are important determinants of who gets into studies. And in many respects, those are the elements that define the sampling frame. So the idea is that in the setting up a study, I'm going to specify what my inclusion criteria to get into the study is and what my exclusion criteria is. One of the projects that I'm working on right now is a count of homeless youth in Maryland. And we have some pretty specific inclusion criteria. Individuals have to be under 24 years of age, be unaccompanied, meaning they can't be living with their parents or even residing with their parents in homeless shelters or on the street. They have to be unaccompanied by an adult. And they have to not have a stable residence. So those are the criteria that you have to have in order to get into our study. Likewise, we have exclusion criteria. So if you can't consent to the interview, you can't be part of the study. We can't have people that have serious psychotic disorders that prevent them from being able to say, I'm willing to participate and give you answers. They have to understand that they're participating in a study in order to participate in the study. A lot of the inverse of the inclusion criteria are also exclusion criteria. So for example, individuals that are 25 are going to be excluded from the study. Kids that are homeless, but are homeless with their parents, are also excluded from our study. So we have an inclusion criteria and an exclusion criteria that defines who our sample is. In looking at studies, you want to think very carefully about what the inclusion and exclusion criteria are. And folks that have carefully documented their studies and their articles will be very clear about what those are. So for example, if you are interested in looking at immigrants, changes in immigrants' mental health status after they come to the United States, but you are only including people in your study that speak English because that's all you've got in your study sample, you're going to have a really strange study sample. That inclusion criteria is going to exclude a lot of people that you should be interested in given the population that you're interested in. So the inclusion criteria and the exclusion criteria need to accurately define the population that you're interested in. And one of the things you can do in critically appraising articles is look very carefully at who they've included and who they've excluded from the study in order to get a sense of what their population and their sampling frame actually are. How many people you include in the study or in the sample, which is called sample size, is determined by a variety of different things. The type of analysis that you're doing. So if you're doing structural equation modeling, you need thousands of people. If you're just going to calculate a couple of means in a t-test to compare those means, which we'll talk about what a t-test is, we're not going to talk about structural equation modeling. But a t-test, like I said, if you have 20 people in each group, you're pretty good to go. You can calculate a mean and a standard deviation from those number of people. So depending on the analysis you're going to conduct for your study determines what your sample size needs to be. And there's something called power analysis that you do to calculate that. Precision is directly related to sample size. If I have a larger sample size, I have more precision. If I have a smaller sample size, I have less precision. What is precision, you say? So earlier I said that the point of sampling is to take a small group of people and have them represent a larger group of people. The larger the small group is, the more closely it's going to be aligned to the larger group of people. And so my estimates, my guesstimate, which is almost always what we're doing, is more and more precise the more people I get. So larger sample sizes result in better statistical procedures. better statistical outcomes, more precise estimates of whatever it is that I'm looking at. So for example, if I'm doing my study where I'm looking at cognitive behavioral therapy for individuals with depression and individuals without depression, the larger the number of people I have in both of those groups, the more precisely I can tell you how much depression is reduced by having cognitive behavioral therapy versus usual care. The fewer the number of people I have, the harder it is to distinguish between those groups because each of my guesstimates gets bigger for those. The necessary sample size is also determined by the the sampling techniques that I use. So random sampling is going to produce more reliable estimates with fewer people than non-random sampling techniques will too. So sample size is dependent on the statistical tests that I'm going to use, the precision that I want, the sampling techniques that I use, and finally, how strong the relationship is. So if I'm interested in finding the difference between cancer rates between smokers and non-smokers, well, lung cancer is much, 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 much higher in smokers than in non-smokers. And so I only need a few people in each of those groups to determine that there's a difference between those groups in terms of risk of lung cancer, since some large percentage of people that smoke will develop lung cancer, whereas a very, very tiny number of people that don't smoke will develop lung cancer. So if I had 20 people in each group, I could really determine the rates of lung cancer in the smoking group, and basically the non-smoking group is going to look like there's a 0 rate of lung cancer, which is not that different from the population at large. So if there's a big difference between my treatment and control, I don't need as many people. But if there's a small difference between my treatment and control, I need a lot more people.